Can you hear me? Hello? I think, hello? I think I can see my picture, photo. Hello? Mrutyunjay is there. Mrutyunjay, you are unmute and speak. Huh. Yeah. Okay. Mrutyunjay? Yeah. Oh, okay. Thank you. Hello? Can you unmute Mrutyunjay? Hello? Unmute. I cannot hear you. Hello? I cannot hear you. Mrutyunjay? You have to unmute. There you are. Some problem. Mrutyunjay, can you
Yes, Professor.
hear me?
Hear you. Hello, sir.
Oh, it's perfect now?
Yes, sir. We can hear you now.
Okay. I think initially there was some problem, but it doesn't matter.
Good morning to everyone. Welcome to the fifth session of the engineering lab that is on sustainable energy from carbon neutral sources. In this session, we have two moderators, Professor Himanshu Tyagi and Professor Balkrish Mehta. So, Dr. Himanshu Tyagi is currently working as an associate professor in Department of Mechanical Engineering at IIT Roper. He has previously worked in the steam turbine design division of Siemens and the thermal and fluid core competency group of the Intel core. He is working to develop nanotechnology-based clean and sustainable energy source as well as water purification techniques with a team of several PhD, master and undergraduate students. The second moderator of this session is Dr. Balkrish Mehta. Balkrish Mehta is currently working as assistant professor in the Department of Mechanical Engineering at IIT Bhilai. He has also worked at IIT Guwahati and as a postdoctoral fellow in ENSM in France and as a manager in Tata Motors. His research area includes experimental heat transfer in two-phase flow in mini and microsystems, heat pipes and thermosiphons, heat transfer of fluids in the presence of magnetic field, droplet dynamics, and evaporation ferrofluid, infrared thermography. With this introduction, I'd like to hand over this session to the moderator, Dr. Himanshu Tyagi.
Thank you very much, Dr. Akhilesh. I hope I am audible. Am I audible?
Yes, you are audible.
Okay. Thank you very much to all the organizers and to the session coordinator for introducing the moderators. We have 6 excellent speakers in this particular session today, which is titled Sustainable Energy from Carbon Neutral Sources. So let me go ahead and introduce our first speaker, who is Professor K.S. Reddy. Professor Reddy is working as professor at the Department of Mechanical Engineering at IIT Madras. He was also honorary professor at University of Exeter, UK for 6 years and adjunct professor at ACSIR CERI, Chennai for 3 years. He is member Board of Governors BOG IIT Tirupati and visitors nominee for faculty selection at various NITs and CFTI. He has organized various conferences and workshops and held several academic and administrative positions at IIT Madras. He has received several awards and is Fellow of Indian National Academy of Engineering. Professor Reddy will give a talk today on solar energy technologies for sustainable and carbon neutrality. So I request Professor Reddy to kindly share his screen by pressing the screen share button at the bottom, and then he may please go ahead with his presentation. Thank you, sir.
Okay.
Sir, do you need some help in sharing your screen? Please let us know.
Sir, I think you got disconnected due to connectivity issues. That's the problem. I just want to inform all the speakers to keep their camera off because we have seen this issue coming again and again. Even if there is slight connectivity issue, you are being kicked out of the session. So, just to make sure.
Hello. Hello. Can you see my slides?
Yes, sir. Yes. We can see your video and we can hear you.
Hello.
But sir, you need to click the screen
Hello.
share button at the bottom.
Hello.
Yes, sir. We can hear you.
Hello. Hello.
Yes, sir. We can hear you. Hello, sir.
Hello. Hello.
Yes, sir. Hello.
Hello. अरे यार. Hello.
Sir, we can hear you.
Hello. Hello.
I'll call him on phone. I'll just calling him on phone.
I can hear you. Can you hear me? Hello.
Yeah, right.
Yes, sir. This is Himanshu. Can you hear me, sir?
Yes, sir. We can hear you.
Yeah. It's some problem. Can you see my slides?
No. Sir, you have to click on the share button
No, sir.
on the bottom.
Slides are not here.
Yeah. I've done that. Now, is it okay?
No.
Huh? No.
It's not visible still.
But I can see here. Hello.
Yeah, but it is not visible
Yes, sir.
at
We can
the
hear you.
platform for all of us.
Yeah.
What happened? I have shared the screen.
Sir, can you try once again? Go back
Yeah.
and click share screen.
Yes, and I have.
Then you have to click that image which comes.
Yeah. Now is it because I have done that and I shared the entire screen.
Sir, if you can send the PPT on email or WhatsApp, we'll share it.
Okay, but you can hear me?
Yes. Audio is there.
But video?
Yes, we can see you also.
But now you cannot see the.
Sir, we can see you and hear you. Only problem is with the screen share. So if you can send us the PPT, we will do that.
No,
Okay. Now.
I suppose that Professor Reddy is.
Hello.
Sir, we can hear you and we can see you, but we are unfortunately not able to see your screen.
But now I can see that. I can see the screen, my slide on the screen. Session 5. Now.
But for some reason, we are not able to see. Would you like to send it to us by email so that one of us can share from here? Dibakar, Can you hear me?
Yes, Himanshu, I can hear you. Thank you.
Okay, I think Professor Reddy got disconnected perhaps. Maybe in that case, since you are the next speaker, can I request you to please
Yeah.
go ahead, and what I'll do is I'll coordinate him on phone and then I'll take him next. Is that okay?
Yes, no problem.
Okay.
Thank you.
So you can go ahead and share your screen. In the meantime,
Sure.
I'll go ahead and introduce you.
Sure.
So we have with us Dr. Dibakar Rakshit, who is Associate Professor at IIT Delhi with 19 years of experience in thermofluid sciences, especially in the design and optimization of energy systems. He has a PhD from the University of Western Australia and postdoctoral research experience at CSIRO, Australia. His special interests lie in energy storage devices, thermofluid studies of solar energy, coupled heat exchanger designs, battery thermal management systems, poly generation, heat exchanger using PCM, energy conservation in buildings, waste heat recovery, and solar-assisted refrigeration systems. Dr. Rakshit has a track record of publishing around 100 research papers in journals of international repute, 14 monographs, and around 50 refereed conference papers. So it gives me great pleasure in inviting Dr. Dibakar Rakshit. So please go ahead and start your talk titled Exploring Sustainable Retrofitting Options for Improving Building Energy Performance in India. Please go ahead.
Thank you, Professor Tyagi, for your introduction. Am I audible?
Yes, we can hear you.
Yeah, so I will share the screen. Just a second. So the slides are visible?
Yes. You may want to go into the full screen mode.
Yeah, sure. So once again, good morning to all of you. Today I will be giving a talk on exploring various sustainable retrofitting options which we can explore to optimize the building energy performance from Indian perspective. Maybe you would have seen this type of scenarios some other place, but when I'm speaking about India and in general Southeast Asia, so how this can be an option, so that I will be showing. So we know that India is actually housing 18% of world's total population. And when we speak about the primary energy consumption, it is only 6% of world's total primary energy consumption. Of course, India has doubled its energy consumption since Y2K, when we started exploring more norms, more avenues related to energy conservation. And then the Energy Conservation Act also came into picture, and eventually you will be seeing that when we were in 2004 2005, the Energy Conservation Building Code, which was also initiated during that time. So when we are speaking about India's contribution in comparison to any other country, the projected
Dr.
rise.
Dibakar, you are muted actually. You have to unmute yourself.
Am I audible?
Yes, sir, you are audible.
So someone told that I am muted.
No. I think it is problem at their end. You are audible. You can open your PPT and start.
Okay.
Dibakar, I think you are perfectly. Please go ahead.
Thank you, sir.
Yeah, please go ahead. I can see you and hear you. Nice.
Yes.
Thank you, sir. So when we are speaking about India's contribution, it is said to contribute than any other country to the projected rise in the global energy demand if we are projecting it for 2040. But in terms of the energy demand per capita, still it is 40% below the world's total average. So you can see that there is a contrast. And if we are speaking about how this energy consumption will be happening, the most important or the key driver in this is the India's urbanization. You can see that there is a trend of people moving from the rural setup to urban areas where we will be having more construction, more energy intensive work being taking place. And when we are speaking about the way this urban population will be developing, so by 2040 we will be having around 300 million people almost living in the urban areas, and which is equal to what United States of America is having today. So definitely there is a need for new infrastructure underlying this huge energy intensive requirement, this demand which we will be having. India's power system will be quadrupling by 2040. I'm projecting it for say next 20 years. And it can be seen that there is a huge requirement of new energy capacity, new generation capacity, which will be there. And of course, renewables and nuclear will be taking one of the important part, but we can't some way or the other eradicate the requirement of the new coal fire plants, which will be also coming up. Now, generally, when I teach energy conservation, so I say that the way we conserve energy is the way we actually use it judiciously. Because if we are seeing from the first law of thermodynamics also, it is the means content is always constant, but it can be converted from one form to another. So if we can judiciously use the energy which is actually available to us, the useful energy which is actually available to us, then we will be not having this type of imbalances which are being created throughout this whole world. So energy utilization is quite critical when we are actually speaking about the energy demand and at the same time the supply which we are having. A very short note, or you can say an example which I want to give over here is, like, if we can judiciously use the energy in the commercial buildings, I'm speaking about the shopping malls or the offices which are not always occupied. Like most of the time the offices are occupied during daytime, so 30 to 40% of this commercial buildings, they don't operate throughout. So if some way or the other we can have this type of demand side management, so that the energy can be judiciously utilized in those commercial buildings, then there will be a huge saving, or there will be a huge evenness which will be coming through the utilization of energy. And of course it will be helping us to reduce the carbon footprint, and it will be making the energy requirement which is there throughout to be more practically used. So now when we are speaking about energy, the highest form of energy which we generally speak about is the electricity. So when we are seeing the urbanization in India, the growth in the building sector which will be coming in the next 20 years, there is a huge requirement of energy, and especially this energy will be driven by the electricity requirement apart from any other forms of energy. Now, in Southeast Asia, in India as well, when we are speaking about the electricity consumption, you can see that both in residential as well as in the commercial area, maximum amount of energy is being required for cooling the building, or for keeping the building or the room to its comfort level, thermal comfort level, because that is one of the norms through which people live a healthy life, so their productivity increases. So of course, if we can some way or the other make our moot point to concentrate on this utilization of energy for minimizing the building cooling load, then in that case, cooling load or heating load, whatever way you want to say it, then in that case we will be saving a huge amount of electricity or huge amount of energy. Now, we cool the building utilizing various active means, like active air conditioner, which we generally have, whether it is a centralized air conditioning system or whether it is a split or a separate unit for each of the individual unit. But there are some passive features which we should promote, which we should take into consideration, which some way or the other has a huge impact in which we can save our energy in these buildings. Now, according to Energy Conservation Building Code, the most efficient, energy efficient buildings can be designed if we are considering it to be efficient through the building envelopes or the facade design. When I'm speaking about the facade, basically they are the roofs and the walls. And what goes in designing those facade? Mainly the correct material selection. It should be local to that environment. It should have the minimum carbon footprint if we are not getting it procured from some way or the other. Now, what is the best way to select that particular material which will be giving us the optimum facade which we can have for a particular building? Of course, there are various factors, like it pertains to the solar convection and radiation which passes through the roofs and the walls. Of course, the windows or the leakages, the services which we are having in the building roofs and building walls, suppose the windows and the doors, through that also there can be some sort of infiltration. And of course, there are internal factors like the lighting area, devices which we are utilizing, and we human being who are inside that control volume, they all contribute to the load which that particular building will be having, and that will be ultimately increasing the air conditioning load which will be required for a particular building. Now, when we are speaking about the building facade, this slide pretty much summarizes what are the various portions through which the heat gets engrossed in that particular control volume. So maximum amount of heat gets engrossed through the roofing as well as through the walls. Like the facade is having main ingredient for increasing the heating or the temperature of that particular building through this roof and the wall. So if some way or the other we can optimize this design, we are directly having an impact on the electricity consumption of that particular control volume. Now, here I will go a bit off, like I'm speaking about thermal comfort, but of course, when we are speaking about the indoor environmental quality, it is not only the thermal comfort, it is also the visual comfort, the type of air which we are breathing inside. This actually will be helping us to maintain less health risk, and at the same time it will be increasing our productivity. So if we are not maintaining it, of course it can be creating some sort of imbalance in the productivity of that particular area. Now, why I'm speaking about this building facade in more details can be understood from our vernacular structures. If we are going to our ancient time, we can see that there are various structures which is having a huge mass. This mass is actually the thermal inertia which is being created by the building facade or the roofs and the walls. But that time we were having the luxury to expand ourselves beyond any limit because space was not the concern. But when we are speaking about urbanization today, we are having the biggest constraint as the space. Now, to maintain the same thermal inertia in that particular control volume or the building, and not to have expansion in the space, some sort of arrangement is to be made to play with the thermophysical property of the building material which we are installing. There comes the requirement of this phase change material. Basically, phase change material has a very high energy density. Energy per unit volume of that particular material is very high, and at the same time it can have this storage of energy more or less at an isothermal condition, unlikely that of the sensible heat storage capacity of any medium which is not taking place in that constant temperature conditions. So these are the beauty of utilizing this phase change material in the building envelopes. And just to make you more aware of it, if you are going to some ancient buildings, say Humayun tomb or some of the forts, you will be seeing when you are going in peak summer, when outside temperature is suppose 40 degrees centigrade, at least you will be having 7 to 8 degrees centigrade lesser temperature in those buildings. And when you are going in peak winter, if outside temperature is suppose say 10 or 12 degrees centigrade, at least you will be having 20 degrees centigrade inside those buildings. This is by virtue of this thermal inertia which that particular building system is having. Now, as I was telling that people are moving from villages, they require houses which will be much more comfortable so that their productivity increases. And at the same time, if we are seeing holistically, the energy gets more or less evenly distributed as and when it is required. So that is the whole area for which we are trying to understand how this phase change material can help us in evaluating the performance of a particular building envelope which comprises of the walls and the roofs. So we have taken the example of Pradhan Mantri Awas Yojana. We have taken the blueprint of Pradhan Mantri Awas Yojana, and in that we have studied the incorporation of this building blocks, the building bricks or the envelopes being sandwiched by utilizing this phase change material, which are actually local to that particular place where it is to be utilized, again on the basis of the climatic condition and the mean average temperature. Over a period of 365 days, we have to pick the actual requirement which is there according to the melting point of that phase change material, which can be stored in that cassetted brick. So this is the gist of this slide. Here I will speak about the type of phase change material which can be utilized, which can be made to be cassetted in those building blocks according to the climatic conditions of India. In India, basically, we are having 6 climatic zones, out of which 5 are quite prominent. By taking the required phase change material according to the melting point, which will be fitting in that particular climatic zone, is a very humongous task which you should always take care of, so that you don't choose the wrong phase change material for a particular situation. So there comes this type of mapping. I have just given some overview of the mapping of the phase change material according to the climatic zone. In fact, it is a big repository. So this is just one overview of what we have done according to the climatic conditions of various places through the climatic zones of India. And the type of arrangement which we have taken in the bricks, according to this this experiment is being conducted at Delhi. So we have taken the composite climatic zone of Delhi, and we have picked those phase change material which is having the melting point in an accordance to the mean temperature of Delhi over a period of 365 days. Of course, we have designed it for summer conditions, because summers in Delhi becomes quite means unbearable. So we have done 3 arrangements. Here you can see that one arrangement is with the brick placed inside the cassetted phase change material, and another one we are having the bricks which are having 2 different arrangements of cassetted material, and the third one was again the bricks with the cassetted material. And in those containers or the cassettes, we have some sort of arrangement to increase the thermal diffusivity of that particular brick. Like we have introduced some fins or some sort of irregularities in those boxes, so that we can actually have more thermal diffusion through bricks. So 3 type of different arrangements we are studied, and then we try to conclude that how much amount of temperature reduction we are finding inside the room in comparison to that of outside. Of course, the experiments were conducted in the month of May, and we found that the inside temperature got reduced to about 7 degrees centigrade for the best configuration which we have taken, and there was a heat gain reduction of around 8 to 12%. And this actually helped us to understand how much amount of energy can be saved when we are having this type of facade, this type of passive features being introduced inside the building. Of course, we will be not getting in one stroke the 24 degrees centigrade thermal comfort temperature which we generally have as the norms of ASHRAE, but at least there will be some reduction in the temperature, which will be not allowing you to go to that much of electricity consumption where you have to cool the air from outside temperature of 40 degree to 25 degrees centigrade, maybe from say 35 degrees centigrade to 25-27 degrees centigrade. So there is a delta of energy savings which you can have by introducing this type of passive features in the building. The next one is regarding a thermal retrofit. Again, with Pradhan Mantri Awas Yojana, we did generally.
Dr. Dibakar,
yes,
this is Himanshu. May I request you if you can maybe conclude in next 2-3 minutes? Is it possible?
Sure.
Thank
I
you.
will do that. Thank you. So basically this building retrofit consists of the insulation as well as the phase change material which are being utilized in the building walls. What we have seen generally when we are speaking about this type of retrofitting, generally the location of the retrofit is known, or the thickness through which this heat transfer will be taking place is known. But to make both the location as well as the thickness of this retrofit dynamic, that type of study has not been done. So again, keeping in mind Pradhan Mantri's Awas Yojana, we have done this type of retrofitting by varying the thickness of the retrofit, the insulation as well as the PCM, and at the same time the location. For example, if you are doing this type of retrofit in Jaipur, it will be different from that what we will be having in Kargil or Siachen Glacier, because exactly the temperatures or the climatic zones are different. So depending on that variable scenario, how we can do the retrofit, this was studied in this study which we have done utilizing genetic algorithm. I will not go into details of it. I will just go to the final blueprint of Pradhan Mantri Awas Yojana. So you can see that the structural and the orientation optimization through this thermal retrofitting, utilizing both the phase change material and the insulation in that particular control volume, can actually help us to reduce the heat gain in that particular building to a considerable amount. And the amount of electricity savings which we can have per day is around 9 kilowatt hours. So if it is being mass utilized, if it can be propagated in mass utilization through Pradhan Mantri Awas Yojana, we can save a huge amount of energy when it comes to this. So I think with this, I will be ending my talk, and if there are any questions, I will be happy to take. Thank you.
Thank you very much, Dr. Dibakar, for excellent talk. And this is a very relevant topic for a country like India, where you rightly pointed out, a lot of the portions are requiring huge cooling load during the summers. So as per the format, we will collect all the questions and we will take it together during the panel discussion round. Once again, I extend thanks to you.
Thank you.
Now I request Professor Reddy. Dear sir, you may kindly share your screen. And earlier there were some technical difficulties. Now you may please go ahead and share, and we request you to kindly give your talk.
Can you see my slides?
We can hear you, sir, and I think we are seeing you. You have to click that button on the bottom. Yeah, now we can see it.
See the slides?
Yes, sir. We can see the first slide. If you can go in full slide mode. Thank you, sir.
Okay, perfect.
Thank you, sir.
Good morning. Good morning to everyone, and thanks to Himanshu for giving me this opportunity. I'll give you a quick summary of various solar technologies for sustainability and carbon neutrality. What I mean solar energy technologies means here it's indigenously developed solar technologies for sustainability. How do we get the sustainability through these technologies, as well as how do we achieve carbon neutrality with these technologies, and how the technology development plays a major role in this. Is it clear? Can you hear me? Perfect.
Yes, sir. Yes, sir. Absolutely fine.
Thank you. Thank you. See, if you look at these energy scenarios, we have generally two types of energy sources: celestial or incoming energy source, and capital, which is exist within the earth crust, generally fossil fuels, and the renewables in this. And then, of course, the reserves are different forms. And if you look at the energy system hierarchy, we have sources, carriers, and equipment, and these sources are transformed into secondary sources of energy and subsequently used as per the requirement. And I will quickly mention about what is sustainability. So energy sustainability is important. We feel that we deserve luxurious systems, but obviously the system technology is very important, and also what is the fuel that is used for these technologies are important. So we want good technologies, and the best technologies are luxury technologies which are imported, and we want to use them because we can afford it. So therefore we use the fuel which is again imported. So importing the technology, importing the fuel, and polluting the Indian environment. So that is a major problem as far as the energy sustainability is concerned. So therefore it is very important. If tomorrow you know that the oil is one of the major energy sources in India for automobiles. In case if some problem in energy source as oil which we import from Middle East and other places, then if we land up into this kind of environment, there is no fuel. So eventually the energy sustainability is very important, because the Earth's atmosphere is surrounded by Earth's atmosphere, and we are talking about global climate change. And in this, we are literally polluting by emitting fossil fuels, and obviously because of that, you have seen recent weather changes and so on. So therefore, the Earth's atmosphere is overloaded with pollutants, which in turn it is getting imbalanced. Any overloaded system will be imbalanced this way. So therefore, energy sources need to be utilized, and if we don't develop our own technology, these resources will extinct after some time. So these are limited and they are stored. So if you try to take the resources, and they will extinct after some time. So therefore, it is very important to come up with a technology which is indigenous technology, so that the technology can keep the resources for the future generation, these sources, and we can take our own share. So therefore, the technology plays a major role, and especially attaining energy sustainability. So therefore, there's one earth we have to take care of, and energy sustainability is very important, and this includes various aspects of energy supply parameters, and energy efficiency, proper mix of energy sources, and renewable energy utilization are the major solutions which make the energy scenario as a sustainable. So therefore, it's important to have a reliable energy supply, and there are several barriers, and bridging the welfare gaps are listed here: transportation bottlenecks, increasing energy demand, domestic unrest, energy investment, market deregulation, energy policy, price volatility, technological development, geopolitical instabilities, and of course, increase in imports. So therefore, energy security is very important, and energy security means it is the continuous and uninterrupted availability of energy to a specific country or region. The security of energy supply conducts a crucial role in decision and that are related to formation of energy policies and strategies. So therefore, any threat to the energy security can be due to natural, technological, human cost, which lead to destruction and damage of environment energy systems, which I have mentioned that if we don't have a proper technology, we have a problem. If you look at the energy services and sources from the day of industrialization, you know that industrialization started in the 1870s. Then since then the transformation of energy is mainly exploitation of fossil fuels has been taken place. And if you look at the fossil fuel exploitation, you know that the hydrogen content in fuel plays a major role. As we increase the hydrogen content, it becomes more efficient and more sustainable, more cleaner fuels. So we are looking at see that gasoline is more hydrogen has more hydrogen content than the coal. So therefore, eventually, if you have only hydrogen, so that's what we are talking about, green hydrogen nowadays. So therefore, producing hydrogen from the first renewable energy sources like solar, wind, and other nuclear energy sources can give a solution for the future energy scenarios. So therefore, there are several challenges to evolving resilient energy systems. So maybe there are key issues and challenges. Because I'm not going to read here, I'm giving you the glimpses because we have very limited time. There are several factors which plays a role in resilient energy systems, so like technical challenges, regulatory and policy frameworks, transmission capacity, and system operations of the energy systems. So then if you look at towards the resilient energy system is an important, it should be flexible, and demand side management is very important. As just now mentioned Dr. Divakar about the mainly cooling and heating loads in buildings and so on. So therefore, it's an important to have a kind of resilient energy system which can cater the requirements of this. If you look at the present system is this, but we may have to go like this, which are decentralized based flexible renewable energy integrated system, which may result in more sustainable and more carbon neutral systems. In the as part of sustainability and carbon neutrality, the important thing is there are various options where various different types of intervention needs to be emphasized on the demand side as well as the distribution side. So therefore, I have listed out here several system operations services from variable renewable energies, load management and flexible generation, transmission. Storage is another important factor, and there is a lot of research is being done on storage side also, both thermal energy storage and electrical energy storage. As a part of that, I've told you that the sustainability, I will give you some of these quickly, some of our technological interventions in renewable energy systems, mainly for sustainability and carbon neutrality. So we have developed
Sir, I think we have lost him.
Hello.
Dr. Tyagi?
Hello. Am I audible?
Yes, sir.
This is Himanshu.
Yeah, you are audible.
We'll wait for a minute. I think earlier also there was some connectivity issue. He may join back.
Sir, please try to keep your camera off, because as I already mentioned, even if there is a small connectivity issue, the speaker is being picked up.
And in the meantime, when Professor Reddy joins back, I may announce that the sequence of speakers is that after Professor Reddy concludes, then we will have Dr. Harish, who is joining us from Japan, and he'll be talking about innovative cooling solution for thermal management of micro-nano electronic devices using atmospheric water harvesting. And after that, we will have Dr. Jagan, who is joining us from Norway. He'll give a talk on the net zero targets and enablers from energy technology perspective. And towards the end, we have Dr. Mrityunjay Shukla, who will be talking about sustainable carbon neutral biofuels. And I think we'll just wait for one more minute.
hello. Okay, can you hear me now? Oh, okay. Sorry. So I'll cut it now. Huh? Oh, sorry. I think there's some instability in the. Can you see now?
We can hear you, and your video is working. You may have to click the share screens button on the bottom, because we are not able to see. Yeah, something is coming. Yes. So, sir, you may have to go back 2 or 3 slides, because we lost you about 2 minutes back. I'll tell you. One more. Yeah, this one. Yeah, maybe next one also. Yeah, from here we were. Yeah, please go ahead.
Yeah, I'm sorry for the loss. So this BioCP we installed in West Bengal in Shantiniketan, the Rabindranath Tagore's place, and it is an integrated system with biomass and solar. And you can see that this is a comprehensive system which takes care of both not only electricity but also cooking gas and water. And this is the system configuration. I'm not going in detail. And based on this system, we have built this and supplied to this village. This village is they don't have any electricity. Completely, it's a remote village, and which consists of about 60 houses, which are like huts. And we have given the power, both power and biogas, cooking gas plus water with this. Can you hear me? Yes.
Yes,
Hello?
yes.
Yes, yes. Okay.
Yes.
Thank you. So therefore, this is the system which is integrated with this is a biogas, and then the solar, and it's integrated with the battery, so that it's a 24 hours supply. And whenever the solar is there, the solar energy is used for the supplying the power. And even there is no solar, then it switches to based on the load management, also switches to the biogas. And when excess biogas is excess energy is produced, it is stored. Mainly during night time, it comes from the battery. So this is a comprehensive schematic of this particular system. So as I mentioned, as a part of sustainability and carbon neutrality, indigenous technology development plays an important role. So our approach is a 4D approach: design, development, demonstration, and deployment is the approach. And of course, through 4E as a tool: energy, exergy, environment, and economic analysis. And through 4Ts, test tube to tabletop to technology development is our approach. So therefore, based on this, we have developed several technologies. I have listed out here 20. Then I'll quickly show that this is our lab at IIT Madras, and we have concentrating solar power technologies like this. And you can see that they're mainly essentially solar dish and trough and so on. So we have come up with an atlas to the entire India, how if the technology is implemented across India, whether it is viable or unviable. And see, these green color places are viable, and blue colors are conditionally viable. Red is not viable with the present technology in present day. So maybe future it may become viable. So therefore, it's a comprehensive atlas, and it will become a tool for the industry people, those who want to install the systems across the India. And this is our, of course, technologies like you have seen: parabolic dish, power. These are, as I mentioned, that our approach is a 4D approach: design, development, demonstration, and deployment. So our technologies can be taken to the field directly. So this is one such system at IIT Madras at lab scale, and we have also implemented in a school close to Chennai. This gives this linear Fresnel reflector based with energy storage. As I mentioned, that the energy storage plays a major role. We have also integrated thermal energy storage with this, and this gives the power and power. It's a tri-generation system, not only power, cooking for the school, this residents of the school, and also air conditioning purpose, plus utensil cleaning, hot water system for utensil cleaning, and so on. So this is a comprehensive. Apart from that, there is a non-tracking system mainly for water desalination purpose. This is a non-concentrating hyperbolic structure and elliptical system which can cater the needs of the water generation, which is a non-tracking system, because passive systems are an important thing. So then, based on this, this is the water. See, as I mentioned, that the food, water, and energy are very important. So this is one such system, multi-tray solar desalination system with the most efficient and with waste heat recovery and using latent heat for this. And I have given you that. And not only water treatment, but also wastewater treatment is also important. So therefore, you know that most of our Indian water bodies are polluted, and treating this water and sending it to the water bodies is important. So therefore, this is the one system which takes care of the treatment of textile effluent, which is located in Tirupur in Tamil Nadu. You know that the Tamil Nadu, this area is actually a textile hub for entire Asia, but now because of the stringent environmental norms, most of these textile industries are under trouble. So therefore, they wanted a solution which can treat the water. So this is another important thing is what we have told you, net zero energy and zero neutrality. So we have also Swachh Bharat, that is an important. So toilet are very important nowadays. So we have developed a zero discharge. You can say solar zero discharge, zero waste discharge toilet. That means there is no liquid, no solid discharge in this, and we used both thermal and photovoltaic energy for driving the system. It's completely hermetically sealed, and the PV power is used to run the motors. And we have a desalination system which treat the water, wastewater, and then there's a dry. The solid material is dried and made into fertilizer and or powder, and which can be reused in this one. And the water also which is treated can also be reused. This is we installed this in one of our students' hostel in IIT Madras in Krishna hostel. So then mobility is another important to get the carbon neutrality. So therefore we that I have given in the first slide how the carbon the sustainability as far as the oil industries are concerned, like automobile is concerned. So we developed, one of my students developed this solar auto, which is again compared, and the cost competitiveness also has been studied, and it is proved that it is better as far as the emission as well as the cost point of view. So these details are here, and it's also published. Those who are interested, then they can do that. With this, I will conclude that the future energy system has to be resilient and is more sustainable, more carbon neutral based system. So therefore, this generation and storage solutions for flexible and efficient system integration is very important. A future electrical energy system may consist of these components, which includes distributed system, electric vehicles, and demand side management, advanced integration of infrastructure, data storage centers, and of course advanced grid and industrialized centralized generation, and so on. So therefore, it's a comprehensive thing. So flexible energy, efficient renewable energy, electricity generation and storage solutions are very important for the system integration and sustainable energy supply. A new concept of integrated renewable energy system has been proposed for a low cost and uninterrupted supply of electricity in mainly rural areas, which I have mentioned earlier. So therefore, with this only we'll be able to achieve carbon neutrality. Thank you very much for patient listening. If you have any questions, please feel let me know. So
Thank you.
yeah, I
Thank
hope
you
I
very
have.
much, Professor Reddy, for an excellent talk. And you have covered the very important topic of the energy systems and their integration with one another, and gave very nice examples. And we will take questions during the combined panel discussion session. Thank you, sir. Now we move on to our third speaker, who is Dr. Harish. Dr. Harish is working as principal researcher at the University of Tokyo in Japan. Previously, he worked as assistant professor at Kyushu University, Japan, visiting lecturer at the University of Edinburgh in Scotland, assistant professor at IIT Mandi. He was also JSPDS postdoctoral researcher at Kyushu University, Japan, and visiting researcher at the Department of Mechanical Engineering in Stanford University, United States. He is a recipient of Henk Board Scholarship for the master's program at Eindhoven University of Technology in Netherlands, and Royal Dutch Shell Personal Development Award for excellence in academics and leadership skills. So it gives me great pleasure in inviting Dr. Harish for presenting his talk. He may kindly share his screen, and the talk is titled An Innovative Cooling Solution for Thermal Management of Micro-Nano Electronic Devices Using Atmospheric Water Harvesting. Dr. Harish.
Yeah, thank you very much, Dr. Tyagi. Let me just open my presentation. Okay, thank you very much, Dr. Himanshu Tyagi, Dr. So it's always a pleasure after making a presentation after Legends talk. So you have put me in a pressure situation, right? So anyway, right, like I try to do justice to the job what I'm doing. So my talk will be on. I assume everybody is hearing me.
Yes, we can hear. One request, Dr. Harish, if you can
Yeah,
make it in the presentation mode, then you can utilize the whole screen.
I have made it in the presentation mode.
Yeah, I mean, you can make it full screen, like press F5 button.
It is in presentation mode.
Okay, yeah, you can go ahead with this also, but right now we are only seeing the smaller icons.
Are you seeing this?
Now we have lost. We can hear you and we can see your video, but you may have to click the share screen button first. We were able to see the PPT file. That was fine, but
This one?
yeah, there's some button at the bottom which says go to the presentation mode. But it is fine. You can go ahead, please.
So what is the data event now? Like for instance, I'm seeing the screen completely.
Okay. You may please go ahead.
Okay. So my topic is about innovative cooling solution for thermal management of micro and electronic devices using atmospheric water harvesting. So there was a great talk made by Professor Dibakar and exceptionally great talk by Professor Reddy about more on the great system level. So what I have to replicate the scenario, the global scenario about the carbon dioxide emission is this. So if you look at the carbon dioxide emission from the 1980 and the prediction till 2100. So historically, so the
Dr.
experimental
Dibakar,
data.
sorry, Dr. Harish, sorry to interrupt you. Are you on slide number 2?
Yeah.
Because we are still seeing the title slide over here. I think now you need
I'm at
to.
slide number 2.
Yeah, but we are still seeing that first slide where your name and today's date appear.
I'm not sure what's happening. I can hear you. What's going on?
Now we can see. Yes, now we can see slide number 2. Energy issues.
Yeah, energy issues. Right. Can you follow it up? Yeah, it's fine. Great.
Yeah.
So historically, the carbon dioxide emission is increasing, even though there is an huge amount of research being put forth to reduce the carbon dioxide emission, but which has not been commercially come into practice. So if this tendency goes into practice, then you will have like a 5 times higher carbon dioxide emission, which is exactly happening now by 2100. But if you have come up with some technologies and which the technology become commercialized, we can probably able to come down to the zero carbon society, worst case by scenario by 2100. So this is a report made by Stanford University and Harvard University. So we are at the verge. Are we going to follow the track of going forward, or are we trying to come up with improving the existing technologies, or coming up with new technologies is subject of question. So what is the source of carbon emission? I restrict this slide to Japan because that's a legitimate data I can able to procure. So in terms of electricity production, so we sort of create like 1,300 metric ton, almost 1,200 metric ton of carbon dioxide per year. And most of the sources comes from the residential electricity generation perspective. And then we spend a lot of money on this residential and the transportation and industrial cost. Of course, there are renewable sources like solar, nuclear, hydro, wind, geothermal, and natural gas. So the total amount of production.
Dr. Harish, sorry to interrupt again. Which slide are you on right now?
Slide 3.
Because we are still seeing slide 2 on the screen. Is it just me or some other speaker? Can they confirm which slide are they seeing?
I am also
Slide
seeing
2.
two.
Yeah, Dr. Harish, I think there is some mismatch. What you are seeing, we are still seeing your PPT, that is correct, but there is some misalignment in which slide number we are seeing. You are
Yeah,
progressing on your computer, but here it's not progressing.
this is weird. Can you have a quick check? Probably because of animation or something.
Yeah, this thing never happens because if you have shared your screen, then whatever you see, we also see over here usually.
Yeah.
But
Can
sometimes,
you see my slide? I'm just swapping around the slides. Can you see the change? I'm sharing the screen, right?
no, this is static image. We are getting the slide titled Energy Issues. On the bottom,
Okay.
it is written slide 2.
So you don't see any changes so far. I have.
No, you may want to like minimize and open some other file or show desktop just for checking.
Then please share your entire screen and then open your PPT.
Sorry, sorry, Dr. Debagar, what you're saying?
So what we are saying is please try to share your entire screen and then go to your PPT rather than sharing just your PPT tab.
Okay.
Yeah, now I think we can clearly see your complete screen.
Okay.
Yeah,
So
perfect. Yeah,
is that
now we can
perfect?
see
Okay.
full screen. Yeah,
Yeah.
slide
Thanks, Dr.
3.
Debagar. Sorry, sorry
No,
for
please go ahead.
glitches.
Please go ahead. Yeah.
Yeah. So I didn't expect this glitch to happen. Yeah. Yeah. So I was mentioning about this carbon emissions from especially from the Japanese side. So this is the exact reality what you're having. This is the data from the Ministry of Energy Resources. So although we have a lot of information about talking about the renewable sources, so still after the nuclear attack, after the earthquake happened in 2011 in Japan, so the amount of nuclear production has sort of taken a beating. So the effort to progress towards the renewable energy sources have also taken a beating. So the whole area of progress is towards improving the efficiency of existing technologies, like how we can improve this petroleum-based production, coal-based production, and natural gas-based production, and how we can come up with some more smart kind of technologies. So for in that case, again, what Dr. Dibagar talked, what Professor Reddy has talked, and what Professor Himanshu Tyagi was actually sort of doing for a long time, including myself. So we have to utilize the things in a better way. So for instance, we have a fuel, 100% energy. So you lose 40% on exhaust gases, 30% on coolants, 5% on friction, and 25% on electric. Efficient power is 25%. So there was a lot of work done on nanofluids, so which hasn't able to become commercialized because now we are progressing towards electrical vehicle devices. So this area of research, what have been done for like 20-25 years so far, is very limited contribution to this from the terms of commercialization. So exhaust gases, we are trying to improve how smart we can do, how improvement we can have. So the one such technology is thermoelectric devices. Again, thermoelectric devices is a very old, outdated technology. Like if somebody asks a mechanical engineer, experimentalist, or electrical engineer, ask how a thermocouple works. So that's how thermoelectric devices work. So the thermoelectric devices, lot has been done. It was a hot topic for last 15, 20 years, which will probably go on for another 10 years, in my opinion. So we are trying to improve there are a lot of people who are trying to improve the thermoelectric materials as such. So huge amount of work, simulations have been done, and how this is going to affect from the device perspective. So that's a question which I'm going to talk about. So in fact, so I'm taking a very particular subject, like what Dr. Dibakar talked, so about building energy. So we are in a society, like huge urbanization is happening, and people are migrating towards from rural society to urban society. So they want smart solutions, they don't want hard solutions. So people are lazy. So we are just trying to have like IoT sensors which are actually dealing with the handling stuff, and then you can get this data, do the processing using artificial intelligence. Data science technologies is available now, and we are trying to make things as simple as possible. These kind of IoT sensors need self-powered devices. So I am working on this project funded by Japan Science and Technology Society. So this is a huge project which started like in 2019 December. So it's like 2 years now. It's going to be happening for like another 8 years. So my perspective is only on this thermal flow control at University of Tokyo. So there are like a lot of senior professors, other people working on other different aspects. I'm just handling this thermal flow control stuff. So what is self-powered sensors using thermoelectric devices? How we can improve that? So that's a very simple topic. I'm going to show the story. Of course, I have worked on this thermoelectric materials in principle using silicon materials. So this is the record-breaking data I published in like 2014. We can actually come up silicon, which is high thermal conductive material, from 150 watt per meter Kelvin. You can bring the thermal conductivity of silicon to like 6 watt per meter Kelvin. So this is a record, is for a bulk material, I'm saying. So this is a record data. You can actually, if you have time, just have a look at this. But I'm saying like from the device perspective, okay, you have very nice material which doesn't work. So the important perspective from the commercialization perspective, from the device perspective, is to have a highly efficient device. So what we thought about like hot side, which is beyond our control, thermoelectric materials, commercially existing material even so, which is beyond our control, we can play around with the ambient situation, make the cold side colder to make the device much as efficient as possible. So what is the trick? So it's a very simple trick. Okay, so in that sense, natural convection definitely existing. Are we going to have like condensation, dropwise condensation, or boiling? For sensors where you don't have space to include anything, any limitation, so you have space limitation, there is no structural integrity, so you have to really cope up with the limitation, and you have to just rely on what things are happening. So evaporation is the best methodology. So how we are going to evaporate water? Are you going to deposit water? No. So you just have to come up with a new framework called metal organic frameworks we worked with, which is a sort of commercial it's not a commercial material. It's a chemical synthesis process, very high porosity, very high surface area, which can absorb water depending on the relative humidity condition. So we made use of that, and we tried like different metal organic frameworks. Like one is chromium based, the other one is like aluminum and zinc based. So for this cooling purposes, in the range of 40% to 60% humidity, you can actually able to see a material which can absorb water from the atmosphere at its own weight. So that was a great sign. So how we are going to do this? Like, so we just code the material, the metal organic framework on the device, and see what's happening around. So we try different materials. One works for a proper humidity ranges, and the one works for arid situation, and one works massively on high humidity situations. So this is a very simple example. Like, so you have a hot side which you don't change, which you don't have control, and you have a thermoelectric device which you don't have a control, and you only have a cold side of the device, which you have proper control, and you just coat it with a porous copper substrate. In this case, what we have done, because porous copper surfaces can also support it by capillary imbibition. So we did a lot of experiments, lot of trial and error, different MOFs. So I'm not going to tell in that in detail. Even the experimental procedures. So most of the experiments were done in the environmental chamber, which is a controlled atmosphere. But real-time experiments were also done. I can show you the results a bit. So the idea is this. So we allow the water to be absorbed inside the environmental chamber, and when you provide a heat pulse and see how this behavior is happening. So how water is getting exhausted and what is of efficient cooling capacity, what you can deliver using coating. So what we actually able to learn from this is far better than what a traditional PCM can do, traditional conventional devices can do. So just by having a coating, like so this is 80% porous copper. If you look at this slide, so it can perform almost 90% better than a conventional heatsink, what is available in a commercial thermoelectric device. So it's just a matter of a MOF coating, 2 times better heat transfer performance. Okay, so 2 times better heat transfer performance is fine, and this became another very, very interesting strategy. I'm sort of hiding this certain results for particular reasons because we have filed a patent about this. So we use chromium based material. As I said, we used MOF 303 is aluminum and 801 is zirconium based. If you look at this mathematical analysis we did and coupled with the experiments, especially for MOF 303 and 801, significant amount of heat transfer is happening because of radiation at room temperature, which is quite weird, right, to understand. And when we did this emissivity analysis, we actually learned that this is 100% emissive. In principle, MOF 303 and MOF 801 are white bodies, but it behaves like a perfect black body. So we get to see this is a very suitable material for radiative cooling, and the preliminary experiments we did shows up that radiative cooling, like what Dr. Dibakar said, it can actually cool just by having a coating. You can cool the substrate from the infrared radiation by 4 degrees Celsius in the daytime, up to 8 to 9 degrees Celsius at the night time. So that was a major experimental work. I'm not showing that slide for particular reasons because we have filed a patent about this, but this is the emissivity data. So how this, in principle, how these kind of materials work from the thermoelectric device perspective. So you can actually see like 6 times increase in the power output, and compared to the conventional existing heat sinks, you have a 70% better performance in this. So I also tend to point out this experiment was done for the device using bismuth telluride device. This is a very conventional existing commercial device. So with new better commercial thermoelectric device coming up, and we are still in the process of progressing towards better technology, better design of MOFs. So there is a huge scope using TEG with MOF coatings will be a very nice solution for self-powered devices. So I sort of summarized this because I was only given 8 minutes to 10 minutes time. So MOF coated thermal fins was developed. So it's this new technology and very scalable and commercially viable technology and lightweight compared to phase change materials. So please think about beyond phase change materials. Okay, and we have like very nice performance improvement, and I will be very happy to answer a question about this, because I haven't shared like a lot of technical details on this. Okay, Thank you very much.
Thank you very much, Dr. Harish, for excellent talk. And this is going to become very important because now the electronic devices are producing heat fluxes which are increasing every 2 years. So for a very nice dissipation of heat and protection of that electronic device, so removal of heat sustainably, very important. Thank you very much. We will have question answer during the panel discussion session. Now we move on to the next talk, which will be delivered by Dr. Jagan. Dr. Jagan Gorale is Program Manager at Cargotec, which is a global leader in sustainable cargo handling solutions and services based in Finland. His working areas include emerging technologies ranging from sustainability, carbon neutral systems, automations, to data and digitalization through national and EU funding projects. Prior to this, he was with Parker Hannifin, a Fortune 250 company, where he was chairing the Innovation Council and leading the R&D activities in hydraulic and industrial process applications. In addition, he served the International Association of Innovation Professionals as an advisory board member during 2020-2021. He has working experience in diverse research and innovation projects in India, France. He received PhD in Applied Fluid Mechanics and MBA in Project Management. Thank you very much, Dr. Jagan, for joining us. Please, you may kindly go ahead with your talk.
Hello. Yes, good morning. Can you see the slides?
Yes.
Am I
Yes.
audible?
Yes.
Right. Thanks for the introduction, Dr. Tyagi, and nice to see all of you virtually. By the way, this is not a technology presentation or technical presentation like the other wonderful speakers did. This is more about net zero targets and where we are standing now as a world, as a global village, and what are the enablers to achieve this one in the next 2 to 3 decades, which is quite interesting, as other speakers already mentioned. So for the audience who are new to this concept, it's the net zero is more to bring a balance between the greenhouse gases production and their removal from the atmosphere. So what we produce from our actions and engineering applications, or whatever we do in the life that brings out greenhouse gases to the atmosphere, we should either remove them or control them so that the net greenhouse gases present in the atmosphere will be zero or close to zero. That's the concept developed in recent times. A lot of jargon is floating around in terms of the tools, technologies, policies, legislation, councils, etc. I tried to summarize most of them that is floating across the globe that you can see in this picture. So if you're interested, you can go into the details of each of these terminology and Google to find more about these things. But what is the takeaway? The takeaway is to limit the rise of a global mean temperature to 1.5 degrees centigrade by when? By when means as soon as possible. Different countries have different targets to achieve this one. But globally, the emission should be reduced as soon as possible, ideally to reach net zero. That means the additional greenhouse gases to the atmosphere should be zero by 2050. The companies like IBM, Microsoft have already announced that they will become carbon neutral or carbon negative by 2030 itself. So as my company, Cargotec. So we already announced to become 1.5 degree company by 2030, and we have a lot in progress. I will discuss those things in the coming slides. But if you look at the world as a single entity, where are we standing? What are the countries doing? You can see on this slide the map that shows in different colors those countries, particularly UK in yellow here, and New Zealand. they already have some laws in place to meet the net zero targets, which is quite interesting. So they are already kind of touch barriers for us. But if you look at the other countries, particularly Europe and USA, they have the policy document that has the net zero targets. So they will make the laws very soon. That is the expectation. Handful countries, particularly in orange, they have the political pledge. So they have already taken the oath to meet the net zero targets as indicated in Paris Agreement and other initiatives. If you look at the other countries which are in gray or gray color, they are yet to decide. But this is the map that is taken just yesterday from the interactive information platforms that show the pledge or the initiatives taken by the countries to meet the net zero targets by 2050. Only by 2050. For example, if you look at India, India has already taken the pledge to meet the net zero by 2070. So that's not shown in this map. So please be careful. This map is only to those countries showing to meet these net zero targets by 2050 only. So the whole world is moving in, I would say, in right direction, but recently the COP26 meeting in Glasgow is slightly disappointing from the technology development or the resource allocation perspective. I don't want to go into the details of that, but we have some information on this slide to proceed further in the next decades to meet this 1.5 degree scenario by 2050 for industry, academia, countries, policymakers, and technology developers. I don't want to go into the details of this very busy slide, but the long story short, by 2021 or 2022, there will be no new oil fields, oil and gas fields, no new coal plants and extensions. The hydrogen usage will be gradually improved, electrolyzers will be gradually improved, and the carbon capture, utilization, and storage distribution technologies will be drastically improved. By 2050, these are quite important to meet this 1.5 degree scenario or carbon neutral systems. So what are the means how to achieve this one? Well, one of the speakers have already mentioned the retrofitting technologies. That's not only to the buildings but to any industry. By the way, this information or the other technological information presented in this conference can be extended to other fields or other countries as well, to in a sensible manner. So these retrofittings can be quite useful, particularly to the materials development industry, for example, steel or shipping industry or aviation industry, through retrofittings, for example. And second is how to reduce the carbon intensive actions both in industry and transport sectors, because these are the industries that are contributing a lot majorly to these carbon emissions. And third is how to develop new decarbonization technologies and fuse them, or if not necessary, then how to diffuse them to develop hybrid technologies within these decarb technologies to meet this 1.5 degree scenario. These are few initiatives technology wise. Few speakers have already spoken about these topics. Now, I would like to give a quick case study of Cargotec, which is my company, which is a global leader in sustainable cargo flow solutions. We have 3 or 4 business companies inside handling the cargo flow and logistics and supply chain activities on the road and ship container management within the ports and the ship logistics. So we have a big chain of logistics or cargo flow solutions that connect different modes of operations. As a global company, as a commercial company, we have our targets, our ongoing operations like R&D, innovation, or how to improve the business, how to enhance the market share, etc. But at the same time, we also have to look at the sustainability aspects, like what we have to think about the people, society, economy, and environment. So those are the things. And recently we have launched this mission Climate, where I'm one of the members of this mission to accomplish our mission, climate ambitions by 2030 and so on. So we already have a quite good roadmap to achieve this one. We have funds allocated. We have a large technology and business partnership with various universities, technology developers, etc., to achieve this CO2 equal introduction. By improving this eco product portfolio, we have already launched a series of eco product portfolios in the market already, and we are enhancing these technologies through electrification, digitalization, robotics, etc. That would improve not only our financial performance but also the customer satisfaction, along with meeting the carbon neutrality as soon as possible. We have signed this agreement in the USA recently to become this 1.5 degree centigrade, where our focus is not only the profitable growth but also the climatic actions. So, how did we do that? We started this journey in 2019 after signing the agreement to become this climate neutral company as soon as possible, through a lot of initiatives to meet this 2030 target line. How do we do that? Because we have to decarbonize our own actions, that is like heating, electricity supply, cooling, ventilation, etc. Those plant operations should be completely renewabilized. And second is how to develop the new products that will be carbon neutral or carbon negative. Electrification is one of them, one thing, but that is about the new products. What about the old products? Can we somehow refurbish or recycle the existing systems to meet the carbon neutrality demands? It's not only about the product that we develop and sell to the customers, but how it is developed from supply chain perspective, from the raw material which is coming from one of the countries in Asia to second level supply chain system and third tier supply chain system, and finally it is coming to the product at Cargotec, and then it is going to the downstream at the users level, and that is again used and then recycled or refurbished. We don't know what's happening at the other end and the first end. We are somewhere in the middle as the product developer. So we want to decarbonize the entire supply chain from the source one to the last end user. So we have already developed those plans. Because of the time constraints, I already cut short my presentation by half. But what are the best enablers as a company or as a society to meet these climate actions, to accomplish these climate actions? This is my perception. Of course, this is subject to change or improvements. First thing is to make synergies between the climate actions and sustainable development, because this is very important. The rich countries or developed countries, they can develop some fancy stuff that may not work for the developing or underdeveloped countries. So we have to make synergies between the sustainable development and climate actions. I don't know how many of you have heard about the coal plant closure in different countries, and then again immediately they had to reopen because they suffered the pain of energy demands by closing the coal plants. So it is not possible to close something immediately, but we have to take gradual steps. And second is the collaboration and coordination. There are challenges between different countries, but how? Because they have their own priorities and their own sophistication in terms of money, time, energy, resources, etc., and technology development as well. But if you look at Asian context, recently there is this ASEAN or Asian collaboration between Philippines and Thailand. Their priorities are different. For example, Philippines wants to become wants to include at least 30% or 35% of renewable energy in their operations by 2030, whereas Thailand is deciding to make all their vehicles carbon neutral by 2035. They defined their actions in different terms, but they have collaborated or cooperated with each other to develop or to meet these accomplishments. So these kind of collaboration and coordination activities are quite important. This is not only among the or in between the nations, but also you can think of businesses, technologies, states, or academia industry that needs the leadership to take the initiatives to bridge the gaps between the entities. For example, if some businesses are there who have a lot of venture capitalists or angel capitalists, and they're ready to put money, but where are the technologies? I clearly see that for example, if you look at the simple CFD technology, some simulations, this is very old and very easy technology to the academia like IITs. But if you look at some companies in Europe and USA, still they find a lot of scarcity in resources to do some simple simulations to save money without going into the prototyping. So there are gaps between the different players. So the leadership has to take initiatives to fill these gaps and bring these technologies into the market, commercialized stages ASAP. And then the next enabler is effective transition, not the drastic, like I said earlier, but gradual. Where it is needed, we can take the big steps, but when it is needed to take the smaller steps or gradual actions, then we have to follow that one. Because, for example, like I mentioned, the quick phase out of coal plants or implementing the complete renewable systems cannot meet the energy demands. We have to use, for example, hybrid or some power to X kind of technologies. We have to slowly initiate the CCUS technologies on the existing power systems, etc. So we have to take small steps to go faster. Agile approach is quite important. And finally, of course, very important, electrification. Either direct or indirect methods can be employed to integrate this electrification in the existing fossil systems in order to, again, gradually become renewabilized or carbon neutral systems. These are the technology or the forerunning enablers to meet the climate actions that are already planned. So this is my quick talk. If you want to have more information, of course, I'm ready to provide, or we can also have individual discussions. Thank you.
Thank you very much, Dr. Jagan, for a very nicely delivered talk. And I must also appreciate that you are the one who is joining it the earliest in the morning. From Finland, I think it was when we started, it was almost 5:30 in the morning. So we really thank you for taking this extra effort. Thank you very much. And we will take questions during the panel discussion. Now we move on to our next speaker, who is Dr. Mrityunjay Shukla. Dr. Mrityunjay is Senior Scientist in the Automotive Fuel and Lubricant Application Division of Indian Institute of Petroleum at Dehradun and head of the Exhaust After Treatment Technologies areas. He is having over 15 years of R&D experience. His area of research are IC engines, after treatment devices, and alcohol fuels. He received the Best Paper Award in the 7th International Symposium on Feedstock Recycling of Polymeric Materials in October 2013, the Young Scientist Award 2017 of the International Society of Energy, Environment and Sustainability, Rashtriya Gaurav Award 2017 by India International Fellowship Society, and the Young Scientist Award of Research Awards VIRA 2017 in the field of automotive fuels and lubricants by Venus International Foundation. Now I request Dr. Mrityunjay to kindly go ahead and deliver his talk. He is present in person. Please.
Good morning, everybody. I hope I'm audible. As a lot of time has been spent, I will keep my presentation fast so that we can save time for the students' presentations. My topic of presentation today is liquid alternative fuels from carbon neutral sources. If we look into the current scenario, there are ethanol and biodiesel which have been partly fetched and researched fuels from carbon neutral sources or biomass, but there are other fuels like waste plastic fuel and hydroprocessed diesel which are not yet established and not much research has been conducted. So I'll be only discussing base things. The basic gap which still exists in the field of biofuels is that we have understood the emission behavior, we have understood the combustion behavior, but we have yet to understand the onboard emission behavior of the fuels to actually evaluate how much contribution they will actually provide in cutting down the emissions in urban air quality. So I will start with the green diesel. Green diesel is nothing but a hydrotreated vegetable oil distilled. University of Petroleum already has integrated technology to produce jet biofuel from hydrotreated, and green diesel is a byproduct. It can be produced from any vegetable oil, edible or non-edible, or a mix of vegetable oils. The beauty or the biodiesel which it has is it is independent of vegetable oil composition. The composition of the output product remains the same, and the CTN number is very high, in number of 75. It also has very high flash point, which diesel we are struggling to be 55 dBc, and we still have in BIS at 35 dBc, and we debate it every time in BIS that for safety reasons the diesel's flash point temperature should be increased. But we have not been able to do so because of constraints in refinery and economic reasons. But with this fuel, we can attain a higher temperature without much effort. That's the beauty of this fuel. Another very important factor is that this fuel is basically not having any oxygen. So the decoming problems or shelf life is much higher than what it is for biodiesel. Now, if you see the chemical properties, as I said, the ash factor, the carbon residue are quite similar to diesel fuel. CTN number is much higher as compared to 5 of diesel, and the viscosity is also very similar. You don't have to push much efforts to actually control the viscosity here. The only concern is the sulfur, which actually remains higher in most of the cases, and has to be treated with this. If I talk about the CSIR IP plant which we have put, it is a 200 per day plant, primarily designed for production of biojet fuels, and it has a co-product of green diesel and green naphtha, which can be optimized by putting temperature and pressure conditions right to produce up to 80% of green diesel and non-biojet fuel. We have passed rigorous inspections for biojet fuels for IAF and other airlines also. We produce has been used for civilian demonstration by SpiceJet. And diesel we have done the tests with our test vehicles in the lab. This is typical design of the plant. You see that if you go for 0 tons per day of block water, you can make up to 5.5 TPD of hydrogen, 0.5 to 0.6 TPD of fluorine gases like H2, which can be recycled to use in the plant, propane and other LPG-like components with the 50 to 55 tons per day range. Naphtha is typically 10 to 15 tons per day, biojet fuel is 25 to 30 TPD per day. Diesel is right now, it is 38 to 40 TPD, but with the optimization of the conditions, as I said, it can be increased up to 30%. Typically, if you see the product distribution, 22% of it is hydrogen, 15% is naphtha, biojet is 28%, diesel 32%, and water 13%. And this is typical photographs of the plant available in the IRP. Dr. Sinha has established this plan. The beauty of this plant is that this is the original process of hydroplating was actually conducted by EOP, but IOP process is a single step process where we go from hydrodeoxygenation to hydroplating in a single reactor and is followed by hydroisomerization of aeroprecipitation, hydroxylation and hydrogenation as it is done in hydrocracker for the petroleum fuels. Now, as I said, we did some engine tests also. So we did a Tata Cummins engine which was rated for 134 kilowatt at 2500 RPM, and engine torque was 1540 RPM. And as you can see, the typical parameters like fuel consumption, hydrocarbons, CO, and NOx emissions all reduce. NOx emissions reduce as compared to biodiesel here because there are two primary reasons. One will be the higher cycle number, which actually cuts down on ignition delay, which means lower flame temperatures and in turn lower NOx emissions. Similarly, the adiabatic temperature is also controlled, so the temperature and the NOx is down. But on the sad side, the particulate emission goes up, which I'm not showing because the series stock we had was having very high sulfur of more than 250 ppm as compared to diesel, which was 10 ppm diesel, and it may be optimized. And then if we have a comparable sulfur, that result needs to be seen yet. So this is the story. We are right now running a test vehicle by Tiago car on this diesel for mileage buildup, and we will see how it is performing in the production vehicle. And get back to the results probably in the next conference. Now, another drop in fuel is gasoline and direct diesel from the base plastics, where the process is based on conversion of polyolefin base comprising of plastic bags and packaging into LPG, gasoline, and diesel like fuels. And we have also done some evaluation in our lab, and results are quite promising. As a matter of fact, India generates 62 million tons of waste each year. That is about 43 million tons, 70% of which is collected, and rest is uncollected. MSW generation per capita in India is 0.17 kg per person per day in small towns, and 0.62 kg per person in cities. Uttarakhand itself generates 900 to 1500 metric tons of MSW per day. A large portion of it remains unrecycled and goes into creating so many troubles. Waste management is indeed a huge challenge for municipal corporations. The waste comes from multiple sources like household, industry, hospitals, agriculture, forest residue, construction and demolition, and waste can be in any form: solid, liquid, biodegradable, physically toxic, and each type of waste requires a distinct type of disposal management. But if you look into this typical composition of waste, typically 8 to 10% of that is waste plastic, which is not biodegradable and poses a serious threat to the environment and marine environment. So, if we, and I have some data here. Yeah, I have compiled some data here for 4 metro cities. You can see the uncollected and litter waste is quite high in terms of waste plastics, and there is a serious need to actually take care of it. waste plastics typically are produced by pre-consumer waste like industry and process industry, post-consumer waste like MSW, agriculture waste, consumers and demolished waste, electric and electronic equipments, end-of-life vehicles. Where does it goes right now? Okay. Most of it is going into landfills, and worldwide it is 40 to 50% going into landfills. Incineration has been a process to get rid of it, but it releases a lot of toxic gases and is not very helpful to marine life. So most of it remains littered here and there, making cities dirty, making environment polluted, and waterways choked. The collection for reuse is only 10 to 50% worldwide. In India, luckily, we have a much more higher percentage of collection, which is standing from 50 to 60%. Now, why plastics? Plastics have been a part of our life because they have large molecules with high tensile strength and mechanical strength, lightweight, cheap, and versatile, and easily produced from petrochemicals and petroleum industry. And they are resistant to moisture also, biological agents also. So somehow they have captured a big portion of our life, and it's very difficult to get rid of them in our day. If you look into the common plastics which we use, PAs, polycarbonates, polyesters, polythenes, high density, low density, or PE type, or polypropylenes. Polystyrene, high-tech polystyrene, polyvinyl chloride, acrylonitrile, butadiene, and so on. Here I have summed up what type of plastic is used in what type of materials. If you look, as I said, that 8 to 20% of MSW is waste plastic, and polyolefins constitute 65% of total plastic waste from MSW. And skip this slide, come to the fuel part, which is most interesting. So IIT, in collaboration with GAIL, actually developed a technology to convert these waste plastics into fuels, which is what is the feedstock for the plant. That plastics made of PPE and PPE, like waste carrying bags, virgin and recycled milk pouches, yogurt cups, fruit wrappers, stuffing, cheese, etc. These can be converted into fuels easily in that plant. Product can be diesel like fuel, or gasoline like fuel, or aromatics like benzene, toluene used in chemical industry. The same plant can produce all three depending on what type of catalyst you use and what type of temperature and pressure conditions you use. So, if you look into a typical distribution, we have done it in large scale, followed by bench scale, followed by pilot scale, and now we have put a commercial plant. We are trying to put a commercial plant in Delhi to run in collaboration with DDA. This is a typical plant which we had at IIT there, which was 1 ton per day W unit, put in August 2019. The technology is supposed to be ready for demonstration by the mid of this year, next year. So these are the typical properties of the gasoline and diesel specifications. And if you look into waste plastic diesel and diesel specifications, you see the density is almost same, distillation range is also same, CTN index is also quite similar, and viscosity is also similar. So it's kind of a drop-in fuel which you can just put into the vehicle and use. We test we did test this tool in one of our diesel and gasoline passenger car. The specifications are given here. And this was done on Indian driving cycle on chassis dynamometer to get the mass emission results. And these are the typical values. You can see that waste plastic diesel actually reduced.
Hello, Dr. Mrityunjay. May I request you to kindly...
2 minutes.
Okay.
Yeah. So this is the test run vehicles, which we are right now running on the diesel to see the long-term effect on the engine. And in conclusion, I can say that wind diesel and waste plastic are two drop tools which can be obtained from carbon neutral sources in future. And if we put bigger plants, they can be cost effective also. Thank you.
Thank you very much, Dr. Mrityunjay, for a very nice talk, where it presented the developments related to getting useful fuels from solid waste. We had one more speaker who was scheduled for today from Australia, but he had some family medical issues, so he apologized and he could not join for today. With that, we conclude the first session, which is the talks by our distinguished speakers. Now the questions are invited from the attendees as well as somebody online. They can type in the question by pressing the Q&A tab, and we will have some discussion for short time among the panel members on the various questions that we have received. So I have compiled some questions which I would like to ask the various speakers, but first let us give opportunity if there is to any of the audience members, or if somebody would like to type in. And in the meantime, I would request all the speakers.
Yes, sir. We have questions from here.
Thanks for the nice talk, and I have a question for the CCUS, which looks imperative and ambitious. But India normally has a pretty high ash-contained coal, and we're struggling with the fly ash emissions. Under these circumstances, where implementation of even ESP has been under question, can we rely on that absorption-based processes which might face challenges related to like the fly ash emissions? So, any comment on that?
Maybe I will request somebody to repeat, because I could only hear some part of the question. If I would like to rephrase, it is something related to the high ash content present inside the coal. And to whom is the question directed towards?
There was a talk on the various net zero options. CCUS was one of the potential options to achieve the net zero. So under these circumstances, when we have a very high ash coal contained and high fly ash contained from the exhaust of power plant, what will be the challenges related to the carbon capture, especially using the absorption processes?
Okay, so now I understand it. Perhaps it's directed towards Dr. Jagan, who had talked about net zero technologies. So you may want to see if you can address the technical aspects, or in more general, what are the advances which are taking place in carbon capture? Please.
I'm sorry, I cannot hear the question very well. Can you again repeat the question?
I think from the audience there is some audio issue, because online we are hearing some echo. So if I may try to do it, the partial portion which I have heard, either somebody can type the question in, or my understanding was that the gentleman wants to know that there are some stocks of coal, especially we know here in India, which are having huge ash content. So when we are talking about the carbon capture technology, how would these kind of challenges, I think the question is more technical. That is the part I could understand. Some parts I couldn't hear. Sir, have I asked the question correctly, or am I missing something?
Yeah, can I
Yes, sir.
respond?
Please.
Okay. So I think the question is based on carbon capture or removing the carbon dioxide from the coal. You know that almost 60 to 70% Indian power plants are based on coal, and with low grade coal, mainly Indian coal. Indian coal contains 40% ash, and generally, you know that India is the fourth largest producer and consumer of coal. But in spite of that, we import coal from Indonesia, Australia, and South Africa. So if you look at the coal's composition, Indian coal contains a lot of ash, but environmental point of view, it is better because it contains only 0.5% sulfur against 2% in foreign coals. So foreign coals good for calorific value point of view, but Indian coals are good for environmental point of view because SOx is a major issue. So here, how do we reduce this? Because you know that when you bring 1 kg of coal to the surface from the mine, almost you are bringing for 400 grams of waste material to the surface. So which is not a useful thing. So therefore, there are various methods by which we can remove or increase the calorific value and reduce the emissions in terms of because we are talking about ash pits volumes. You see, nowadays most of these thermal power plants are huge ash pits, and we are talking about solar integration with coal-based power plants. So therefore, there are mainly basically three methods by which we can reduce the carbon dioxide. One is going for IGCC is one. The other one is a coal bed methane. So you produce underground the gaseous fuel from coal. The other one is end of the pipe. We call end of the pipe. End of the pipe is after burning, then how to remove the pollutants, mainly carbon dioxide. For that, there are several technologies. Mainly these are carbon sequestration. Mainly large beds are there. Apart from that, another method is to go for fluidized bed combustion. These are some of the methods by which we can reduce the carbon dioxide. Thank you very much. I hope I have answered.
Okay. Thank you very much, Dr. Reddy. Thank you.
Thanks, Reddy sir. You answered much better than me.
Thank you. Are there any other questions?
May I?
Yeah.
Okay. So my question is to Dr. Shukla from IIT Dehradun. So I have a couple of questions. The first one is like it's a really great work what IIT is doing in this alternate fuels, and I am much aware of their work otherwise also. So I just want to ask, first of all, one of the most difficult plastic which we are facing the challenges is the PVC. So is there any work in planned or you are doing anything on the PVC conversion? I'm aware only of one plant in Japan because of this chlorinated component. So they are converting the vapors to HCl. So otherwise, I have not seen much work in the commercial space on PVC conversion. That is my first question. The second is what I could understood that I could understand that you are working on the waste plastics. So how this different contaminations in this, because we have no control on this, how it affect on the overall quality, and how you take care of that before purification. So that is, and my third question is if you can share the waste plastics in India, the reference of that data. So these are my three questions. So you are here, so you can.
As far as the PVC is concerned, right now there is no work going on in IIT. We did try something, but it doesn't work. I'm not at liberty because of the salary is the right person to comment on it. I'm not much liberty to speak further on this thing. As far as the second question is concerned, um, right now we are doing it manually actually. We redesign the mechanical device to clean it up through water washing right now, recommendations. So that's what we are doing right now washing. But we are looking for more practical and more efficient solution actually, which we might in a couple of months come up with. As for the third question is concerned, can you repeat?
That was that data you showed for the Indian plastic generation, waste plastic generation. If you can share the reference of that.
I see. I not right behind it, but I have your email ID, so I'll share.
Thank you.
Thank you, Dr. Mrityunjay. Are there any other questions from the audience? Dr. Balkrishnan, would you like to ask some questions?
Yeah, I have one question which is not completely technical. So, probably Professor Reddy, I'll direct to him that when we talk about sustainability in the energy, sir, do you think that it's only a matter of technology? I mean, just with the help of technology, we can deal with this carbon producing thing or the issue of sustainability, or it requires some more changes in our daily life? I mean, just to elaborate on it, for example, Dr. Dibakar showed the use of PCM, right?
Dr. Balkrishnan, let me check. Is Professor Reddy here? Because I can't see him anymore. Maybe he got disconnected.
Okay. So maybe Dr. Dibakar or Dr. Harish, I mean, as they showed the way to just have the things which are better to cool, or Dr. Rakshit showed that sustainable housing using the PCM. So what is the take? I mean, it's a matter of technological development, or it requires some attitude also.
Right, like I will answer this. Like both are partially correct, but like it always from the commercial perspective. So whatever any kind of technology you develop, it has to be user friendly and user have to afford it, right? Like it's not like anybody can go and buy an iPhone or like some exhausting stuff like this. So this is when it comes to like building construction, for instance. If certain things can be made at a price of, let's say I can build an apartment or like house at the price of like 20 lakh rupees. And if you exceed this cost by saying like have a new technology which can afford better futures, but you expect the price to be like 30 lakhs, people will not come to that, right? Even including me. So it's 33% more. So we have to be very careful about that also, right? So in that context, so better technology is important. On the other hand, we also have to be very careful about what is the price range we can put, the burden we can put on the person. It has to be affordable, it has to be friendly. So that is the most important thing. For example, like in Japan, let's say, like you have fuel cell buses running here. So the cost to go in a fuel cell bus compared to a hybrid bus is 20% expensive. And there are not a lot of fuel cell buses being run in Japan because customers doesn't like to go. So that's even for a developed society. So when for a developing society, we have to be like even more very careful about cost, irrespective of the situation. Of course, developing technology costs a lot, but on the other hand, for the users to afford, we cannot force them to buy it, right? So we have to be very, very careful in terms of pricing. So how simpler, how economical. we can afford, that is going to help them a lot. Yeah. Of course, customers want the best, people want the best at least pricing, not at the heaviest price. So that is always the thing which we have to keep in mind. Yeah. So Dr. Dibakar can probably answer better. Yeah, sure.
Thank you, Dr. Harish. So I think you have covered all the avenues which I wanted to touch base. But generally, like I will just give a small example. In my energy conservation subject, I tell my students the last day that if you understand what is the importance of switching off power when you are going out of a room, then whatever I taught you in this semester, it is worth it. And if you don't follow it, then I don't think there is any point in conveying this lectures. So there is a very thin line between energy conservation and energy efficiency. So when we are speaking about from the technical viewpoint, it is energy efficiency of any system or any device is quite important. But when we are speaking about the soft skill or the thought process through which this energy efficiency is to be enhanced or optimized, it is all people driven. So unless we are making ourselves aware, because numbers are there, it is all evident from whatever analysis techno-economics people are doing. But until and unless we are sensitizing people to take it to their day-to-day life, it is not a very good thing. So that's what, as you rightly mentioned, it is not only the technology, but also the person who is actually employing that technology should carry it forward. Thank you.
Oh,
Thank you very much.
Can I just add one comment here? So there is whenever we develop the technology and put that into the market, there is an aspect called socio-economic or social aspects attached to that. Obviously, there will be enough studies done beforehand before putting that into the market. Apart from that, it's not only the social thinking, but also the companies. They think a lot. So there is something called work culture or company's culture. So they induce that one into the company before developing the technology, and that will be transplanted or transformed into the society before developing the technology. So obviously all these are interlinked.
Thank you very much. So with that, I've just received a note from the session coordinators that some student presentations are awaited. These are very short presentations, and we have to listen to them in the video mode. So one of the volunteers will play it, and we have already received through email some evaluation sheet. So I request all the panel members, the speakers, and the moderators to kindly go on evaluating, and we can also ask brief questions at the end of each video. So I now request our volunteers, kindly please go ahead and play the first video.
Good morning to all. My name is Avinav Rajan. I am research scholar in IIT Madras. I am here to present my work, optical modeling of solar parabolic disc collector coupled with the conical cavity receiver. First, I will start with the background and motivation. As we know, solar energy is eco-friendly and available in plenty throughout the year, so we can use the solar energy to meet our energy requirement. Here we have considered parabolic disc collector, which is used to reflect incoming radiation to a receiver. We can see the details of receiver here. The receiver is conical in shape. This is inner and this is the center wall. In order to optimize the performance, the selection of receiver is very crucial. It should capture more incoming radiation, so it should be optically optimized. In present study, we are optimizing the various parameters such as aperture opening, surface observability, location of a receiver to achieve the optimum performance. Now I will talk about the method involved in the study. Here we have 40-meter parabolic disc collector having the dimension of 45-degree rim angle and focal of 4.3 meter. The reflectivity of the parabolic disc collector is set to 92%. This is a receiver. the inner wall and side wall of the receiver are considered as the absorbing surface, and the absorbability of this surface are varies from 25% to 95%. The Monte Carlo ray tracing method is used in ASAP software. The ASAP software is an optical tool. The number of ray coming from source is 0.1 million, and further increase in the ray has a marginal effect, and the model is validated with the experimental work and holds a good agreement. Now I will talk about result and discussion. So in order to optimize aperture plane diameter, the optical analysis is carried out, and it is found the optimum value is at 0.5 meter. Further increase in diameter, the observed heat is almost same. This is a spot diagram at the aperture plane for 0.5 meter aperture plane diameter. At the center, the heat flux is very high, and it gradually decreases while going towards edge. And same thing justified by the heat flux curve. Further, the effect of observability is carried out. In this diagram, the observability of inner wall is varying, and we can observe at the higher observability, the optical efficiency is more. This diagram is showing effect of overall surface observability on optical efficiency, and at the higher observability, the optical efficiency is more, and optical performance is found at height of 4.2 meter, which is 90%. Now conclusion. Based on optical modeling, the following conclusion can be drawn. The optimum value of aperture is found to be at 0.5 meter, and the heat flux distribution having a good fit with Hurd square is 0.965, and further inner wall observability of 95% was performing good compared to other value of inner wall observability, and also overall observability of 95% performing good, and it provides 90% optical efficiency at a height of 4.2 meter. Thank you for your attention.
Thank you very much, Abhinav. Are you present for some questions?
Yes, sir. Yes, sir.
Okay, yes, we can see you now. Very nice presentation. So now we invite questions from audience and from panel members. Are there any questions? Maybe I will ask one question. Abhinav, can you hear me?
Yes, sir, I can hear, sir.
Okay. So my question is, you have done very nice work. What is the role of the inner wall absorptivity? What role does it play? Do you want it to be very close to 100%, or even if little bit less value, then it is still optimum? Can you comment?
Yes, sir. In parabolic disc collector, the most of the ray is coming to the center. So by the varying of inner wall observability, we can estimate the optimal value of performance.
Okay. So would you still want it to, because I was thinking from the cavity shape point of view, that sometime we see that for a cavity maybe less than 100% also it will work because all the rays are trapped, or do we want to go close to 100%?
Sir, if we go, but it's ideally we can't achieve 100% absorbability of the surface.
Yeah. I think we are already very close to that, right? 95%. That is good value. Okay. Thank you very much. If there are no more questions, then let us move to the next talk, and let us thank Abhinav. Thank you. Can somebody play the next video?
My name is Ravi Raj. I am here to give personal presentation on the topic of a review on the application of waste and materials to enhance thermal comfort of buildings for 6th International Conference on Sustainable Energy and Environmental Challenges. Background and motivation. The constantly rising demand for power, the degradation of carbon fuel sources, and even the recent climate change all seems to be undeniable realities. So, working to improve building insulation and implementing renewable sources of energy are getting increasingly central concerns of population for limiting energy consumption and increasing power consumption. The studies data indicates that in summers Whenever the estimated average outdoor temperature is about 31 degrees Celsius, the thermostat of lightweight buildings can surpass 42.5 degrees Celsius. As a response, the heat and materials are now the subject of research to improve lightweight constructions fuel heat inertia. Maria Terpstra, a Hungarian researcher, was the first one to propose heat-chain material for collecting heat energy that she implemented in 1948 to store the energy for just a solar house construction. You can see a graph between number of articles to year 1997 to 2019. The graph shows an ever-increasing trend of the number of published articles about PCMs used in buildings. So it can be predicted that in near future it will even grow and the demand of PCMs is going to rise. Methodology: PCMs can be directly mixed with the cement concrete with various binder materials. PCMs are used in walls such as solar walls or energy-efficient walls. PCMs can also be used in floors, roofs and wallboards. In the figure you can see how PCMs can be used in solar walls or energy-efficient walls. Results and discussions. The effects of concrete alterations and improved PCM insertion processes were shown to increase heat energy storage by up to 300%. The thermal comfort was improved without the need of an air conditioner. The element which absorbs part of heat from the sun's light in daytime initiates the melting process. As the PCM hardens over the night, it dissipates the heat it has absorbed. After around 8 hours, the PCM was able to completely retain the heat or thermal energy, and after 6 hours, it could even keep 70% of heat energy. Conclusion: climate conditions must be considered while evaluating the performance of PCMs. Optimal phase change temperature of PCM should be in the range of 18 to 35 degrees Celsius in order to achieve thermal comfort parameters. Thank you. My presentation for today is now over.
Thank you, Ravi. Are there any questions? Is Ravi present, either physically or online?
Yes, sir.
Hello, Ravi.
Yes, sir. Am I audible?
Yes, we can hear you. So let us see if there are some questions. So panel members, would somebody like to ask question?
Yeah, Mr. Tyagi, can I ask
Please,
one
Devakar,
question?
go ahead.
Thank you. Good morning, Mr. Raviraj. Am I audible?
Yes, sir. You are clearly audible to me.
Okay, thank you. So you are speaking about utilization of PCM in buildings, right? To save energy. So is there any important feature which we should keep in mind when we are going for retrofitting about a PCM? Means we know that comparing to Sensible, this latent is having good qualities, which always prescribes it. But within the phase change material, is there any important feature which we should keep in mind?
Within the phase change material, actually, sir, phase change materials are basically feature wise. If you consider, then we consider the features of latent heat temperature range, which should be optimally between 18 degrees Celsius to 35 degrees Celsius. And structure wise, then you have to go in encapsulation methodologies that are currently or used in market and available in abundance. But my review paper is basically focuses on its application in solar walls or building energy efficient walls.
So just wanted to know, is cyclability a very critical thing? Like by the time the sun sets, it starts discharging, and again, means whatever way you want to understand charging and discharging, that cycle, is it important when we are retrofitting the PCM in the building walls and roofs?
Yes, sir. Cyclic. Actually, the presence of sun is very important for latent heat gain by the PCM to melt and just store the energy and then release in the night.
So I think we should consider that.
Yes, sir, intermittency is considered.
Yeah, okay. Thank you, Mr. Raviraj. Professor Tyagi, I'm fine.
Thank you, Dibakar. Any other questions? If not, let us thank our speaker, Ravi. You have done nice work. Thank you. And we now move on to the next video.
Hello everyone, my name is Prashant and I'm a research scholar at IIT Mandi and working under the guidance of Dr. Akuldhar and Dr. Satyajit Pawar. And my paper title is The Performance Evaluation of a Parabolic Trough Collector with an Internal Triangular Helical Wire Coil Flow Insert using a different fluid. As we move to the background and motivation, the parabolic trough collector is the most proven solar concentrator for the indirect generation of the steam in solar thermal power plants. The parabolic trough collector is simple to manufacture as compared to the dish type and the compound type concentrator. Then by using a parabolic trough collector, the solar radiation is focused on the absorber tube up to 40 to 50 times, and hence the heat transfer fluid is heated up to 300 to 400 degrees Celsius. The parabolic trough collector having the three main parts. One is the reflector, second one is a heat collector element which we called as a absorber tube, and third one is a glass tube which is used to prevent the heat loss to the atmosphere. When the heat transfer fluid passes through the absorber tube, it gets heated up. And in order to increase the performance of a parabolic trough collector, we have the two main methods in the literature. One is using of turbulators, and second one is the nanofluids, in which the nanoparticles are added into the fluids. The primary goal of this study is to enhance the convective heat transfer rate between the absorber tube and the heat transfer fluid. Thus, we can increase the overall efficiency of a parabolic trough collector. The methodology which we have adopted is, firstly, we have developed our own in-house developed the code based on the Monte Carlo ray tracing algorithm using parallel computing, and using this code we find out the non-uniform heat flux on the absorber tube. And when we compare our code with the Jeddi Chang et al., we have find out the deviation of less than 2%, which confirm our reliability of our new algorithm. After that, we have built a model on the Fluent, and which we compare with the Blanco et al., from where we can find out the deviation of less than 1%. Then move to the resultant discussion. We use different type of the working fluids and run it for the different mass flow rates. So for so we have the thermal efficiency with inlet temperature and mass flow rate for water, then thermin oil, then molten salt and the liquid sodium. And after that, we use gaseous fluids. One is for the air, second we use the carbon dioxide, and last we use the helium. And we find out all the exergy efficiency and the thermal efficiency for all the working fluid, and at the end we compare all the 7 working fluids, all their thermal efficiency and the exergy efficiency. So at the end we find out the conclusion that we have studied the broad range of temperature which varies from 300 to 1300 Kelvin for the 7 different fluids. And from the sensitive analysis, we find out the low temperature range working fluids, the pressurized water is suitable, and for the higher temperature range, we have the liquid sodium, which work up to the 1100 Kelvin, and beyond that, the carbon dioxide and helium is suitable. Thank you.
Thank you, Prashant. Are you available?
Can you hear us? Yes, sir.
Okay. Nice work. Let us
now invite questions. Yes, sir.
From panel members.
Prashant, I have a question. Can you hear me?
Yes. Please go ahead.
You are audible, sir.
Prashant, so why do you have to do this Monte Carlo calculations for this, right? You can actually able to predict the performance parameters from the thermophysical properties data, right?
Yes, sir. Right? Yes, right, sir. Exactly right. But in order to, in the actual scenarios, sir, in the real world, you cannot apply the non-uniform heat flux. You cannot provide you by yourself, because as the sun rises from morning to evening, the solar radiations keep on varying. So that's why the flux coming toward the absorber tube is also keep on varying. So in order to simulate all those things, means the non-uniform heat flux on the absorber tube, I develop a in-house code and calculate the non-uniform heat flux and use it as a input condition in the fluent. So then that's why I do that with the help of Monte Carlo to replicate the actual scenario, sir, in the real world scenario.
Yeah, but this is
Yeah,
still a
but
tricky,
this is
tricky
still a
question in the
tricky
sense
question in the sense. Yes, sir.
when you are
When you
dealing with a high temperature. So, like for instance, you are handling above 600 degrees Celsius or 700 degrees Celsius. So the boundary condition
Yes, sir.
of having a constant temperature or constant heat flux doesn't matter much.
Okay.
So in that
So in
sense,
that sense, you
like
know, like
water
water
will
yes,
be in
yes,
gaseous
yes,
form on that
gaseous form on
temperature,
that
right?
temperature. Yes,
So
sir.
you have
So,
very
yeah, yeah. You have
limited
very
fluids to deal
limited
with it,
fluids
right?
to deal with it, right? Yes, yes, right, sir. So that's why we have we have done the study from 300 Kelvin to up to 1300 Kelvin. So for the low temperature range, up max up to 500 Kelvin, the pressurized water is best suitable in our study. And for the medium temperature range, we have the molten salt, which is the molten salt of sodium chloride and potassium chloride, which is best suitable up to 800 Kelvin. And beyond that, we have the liquid sodium, which will be having the highest exergy efficiency and the thermal performance as well.
Okay, great.
Okay,
Thanks.
great. Thanks. Okay, sir. Thank you.
Thank you, Dr. Harish. Are there any other questions? Because I think somebody has raised hand in the Q&A. Would they like to type or ask the question? Please go ahead.
Sir, they will not be able to ask questions. It is actually the people who are presenting that are raising their hands, and after that we are allowing them on stage. They are not questions from all.
I get it. So if there are no more questions, let us thank our speaker, Prashant, and we move on to
Hello all, my name is Abhishek Raj. In this conference, I am going to talk about my work, understanding the behavior of lead-free perovskite solar cell through computational approach. So as we all know, the power conversion efficiency of perovskite solar cell reached up to 25.2% in just 10 years, but the lead present in perovskite solar cell restricted its further application. So here we designed a lead-free perovskite solar cell using LNMO as a absorbing layer. Initially, we optimize our device according to the experimental measurement, and further we optimize the various parameters of the perovskite solar cell and enhance the power conversion efficiency of the device. So this is the virtually designed solar cell in SCAP simulation software. Here we use TiO2 as electron transport layer and CUI as a full transport layer. Initially, we performed the DFT study and optimized the band gap of absorber and received optimized band gap of 1.11 electron volt. Further, we optimized the different parameters, defect density, doping concentration, and thickness of the absorbing layer, and observe the performance of the device. So we can see once the defect density and doping concentration was less, the recombination rate was also less. But once the doping concentration and defect density increases, the recombination rate is high. That affect the performance of the device. In the similar condition, once the thickness of the absorber was less, the power conversion efficiency was less. But once the thickness of absorber was optimized, the device given improved power conversion efficiency. We have also observed the quantum efficiency wavelength CARA according to the variation of thickness of the absorber. Further, we performed the simulation study with different electron transport layers, and we found that TiO2 and C60 can be a good electron transport layer with LNMO based devices. In the next study, we varied the work function of front electrode material, and we found that once the work function was less than 4 electron volt, no electrical barrier formation takes place. But once the work function increases from 4 electron volt to 4.2 electron volt, the electrical barrier formation takes place, and that affects the device performance. Finally, it can be concluded that we designed a perovskite solar cell, lead-free perovskite solar cell in SCAP simulation software, and by optimizing various parameters, we enhance the device efficiency of the solar cell up to 15.42%. Thank you. Thank you for your attention.
Thank you, Abhishek. Let us take some questions.
Dr. Tyagi, this is paper number 132. There is a small change in order, so please make note.
Yeah, what we heard was paper number 132. Yes. Let us invite questions from audience members or panelists. Is Abhishek with us?
Yes, sir. Good morning.
Hello, Abhishek. Good morning. Good
Mr.
morning.
Mr. Abhishek, do you have time? Can I ask some questions for you?
Please, go ahead.
Yeah. So it's nice to see the phonon spectra from your DFT calculations. Like I'm very happy to see that first. Yeah, but on the other hand, like I have to ask this question: like 4.2 electron volt is still a huge band gap, right? So do you think it's a better solar cell device, this perovskite material?
Sir, I optimized the band gap of LNMO as 1.2 electron volt. This is and in DFT, actually the band gap of the LNMO according to the developed configuration for perovskite solar cell, we have received optimized band gap of 1.1 electron volt for DFT, which is a good band gap for lead-free perovskite.
Yeah, 1.1 electron volt is a good number, but
yes,
from the results you showed is like around 4.2, right? So you're trying to reduce the band gap by tuning the material properties? Is that what I'm trying to understand?
Yes. No, sir. Actually, 4.2 is not that band gap. 4.2 is the work function of electrode material, which is the front work function. Like we use the substrate like a glass substrate, and the work function of that fluorine doped glass substrate is if more than 4.2 electron volt, the barrier formation take place. But so we need to use the substrate which having work function is must have less than 4 electron. That is the work function in last.
Okay. So your objective is sort of 1.2 is something similar to silicon based.
Yes, sir. Yes, sir.
PV cells, right?
Yes.
So that's what
yes,
you're
sir.
trying to achieve.
Yes,
okay.
Sir.
Great. Thanks a lot. Yeah.
Thank you very much.
Thank you, Dr. Harish. Anyone else would like to ask questions? If not, let us thank Abhishek for nicely done work and nicely presented. Thank you, Abhishek. And then we move on to the next paper.
Effect of overhead type rectangular enclosure on thermoelectric performance of PVPCM model. I am from Department of Mechanical Engineering, IIT BHU Varanasi, and I am here to present my topic. And my topic is basically, we see that pollution is driving more deaths compared to COVID-19, and we can say it is a very serious issue causing air pollution, global warming, sudden climate changes due to exponential growth in population. So we need to move towards renewable energy sources, and in particular with renewable energy sources, we need to move towards photovoltaic panels because it produces clean energy. But due to temperature rise, its performance deteriorates. So we use PCM and we use PVPCM system to generate electricity, which can produce cleaner energy and at a higher performance rate to meet that global energy demand. But even conventional PV systems have a problem of temperature increase in later stages of melting, hence modification of encapsulation is required. And what we have done, we have modified the design of encapsulation to overhead type, and these are the boundary conditions given to the system. We can see there is a solar radiation and there is a radiative and convective loss, and heat is being stored in the PCM, and all other boundaries are insulated. These are the boundary conditions, and these are the governing equations. Mass is conserved, momentum is conserved, and energy is conserved for the PCM enclosure, and energy is conserved for PV and glass layers. And this is how we calculate the power output and efficiency of the PV panel. And now we come to the real-time discussions. We can clearly see from the melting front contours that in conventional system, the melting is getting slowed down in later stage of melting, and the temperature of the PV panel has increased in the upper region of the enclosure. Here, when we modified the design, we have seen that the uniform temperature distributions, and we can clearly see here in the graph that nearly 60 degrees Celsius of temperature is maintained for simple PV system, which is decreased to 46 degrees Celsius in conventional one, and which is further decreased to 34 degrees Celsius in modified one, and it is more uniform compared to the conventional one. Now we can see the liquid fraction has also increased because melting has increased. So this is nearly 10% increase in the melting, and due to which the efficiency approaches to 12% for the modified system, which is whereas the rated efficiency is 12.4%, and the total utilized radiations also increases since the modified system generates more electric power and store more heat. So here comes to we comes to the conclusion of the PPT that our PV panel in modified system works at 96% of its rated performance, whereas in conventional system it was 93% and 86% in simple PV system. And heat storage capacity of our type system also increased by 10% compared to conventional system. So we can say that it generates more electric power, it store more heat, so it is a more efficient system and a cleaner source of energy, and it can be a viable option that can reduce the carbon emissions of the surrounding and lead to a pollution-free and clean environment. So we can move inches closer to the cleaner options of energy, and it can be the modified system can be a good replacement for that. This is thank you, and this is my information. I'm Akshavir from Department of Mechanical Engineering. There is a research scholar there. Thanks. That's it.
Okay, thank you very much, Akshavir. Are you present today to answer some of the questions?
Sir, he is not present. Hello?
Yes, what about online? Has he joined online?
No, sir.
Okay,
He has
okay.
raised his hand, so we can't ask.
Okay, maybe some difficulty is there. In that case, if he is not present, let us move on to the next paper.
Hello everyone, my name is Amit Kumar and I am a scholar in the Department of Mechanical Engineering, IIT BHU Varanasi. The topic of my presentation is performance enhancement of solarator by using sustainable material. First of all, I talk about background and motivation. A solarator is a simple solar thermal device which is used to heat the air by using solar energy. In this figure shows the conventional solarator in which solar radiation falls on the glass surface, some part of deflected and major part is transmitted to the glass and absorbed by the absorber plate. So when the cold air is falling through the channel, it extracts the heat from the absorber and exits from the outlet. This solarator can be used different applications: room heating, natural ventilation, timber staging, paper mill, drying of agricultural product. Solarator has certain disadvantages. It has low thermal efficiency, higher hydraulic losses, not stable at night due to unavailable solar energy. The performance solarator can be enhanced by using such material. This because such material absorb and release the energy during sunshine or offshine hour in the form of latent heat. It increases the operational time, it reduces of losses. Second, I talk about methodology. This figure shows the schematic diagram of different types of solarator which is used for the numerical work. These are the methodological parameters which is used for the numerical work. Table 1, table 2 listed the geometrical, optical, and thermophysical properties of different types of material which is used for the numerical simulation. These are the governing questions and these are the boundary conditions which is used in current numerical simulation. The third topic is result and discussion. Figure 3 shows the comparison of liquid fraction between numerical work and experimental work of Kalmari et al. From this figure, it is found that maximum error 4.67%, which is below the 10%. So this model can be used for the numerical work. This figure shows the outlet air temperature variation with the time of day for different type of solarator. From this figure, it is found that with the increase of the time of day, outlet temperature increases or reaches maximum at 1 p.m. then after decreases. The maximum outlet temperature has been seen curved double pass solarator as compared to flat double pass solarator. Figure 5 shows the solid liquid interface evolution during melting and solidification of curved double pass solarator, flat double pass solarator. From this figure, it is found that higher melting rate in plate developed oscillator is found as compared to curved developed oscillator. This is because due to centrifugal force, secondary bodies formed near the absorber which take the maximum amount of heat from the absorber, so the melting rate delay in curved developed oscillator. However, solidification process is same both type of oscillator. The last topic conclusion, the descending order of maximum outlet air temperature as curved developed oscillator, plate developed oscillator, and plate single oscillator. Complete melting and solidification occur 12 p.m., 7 p.m. respectively. Maximum absorbed plate temperature has been seen at 12 p.m. in all types of oscillator. Descending order of top heat loss from the glass surface, curved developed oscillator, plate developed oscillator, plate single oscillator. These are the differences which is used for making this presentation. Thank you everyone for listening to my presentation.
Thank you, Amit. Is Amit present to answer the?
No, sir. He's not.
Okay. I think in that case, I think we have finished all the paper presentations, right?
Yes, Dr. Taggi.
Yes. Can you hear me?
Yes. I think all the contributed papers are completed now. Now it's time to honor all the speakers. So most of the panelists are present virtually. So I would like to thank all the panelists and moderators for their valuable thoughts and the knowledge. And now we have one of the panelists who is present here. So I would like to request Professor Avinash Kumar Agarwal. Yeah, I would like to request Professor Avinash Kumar Agarwal to come on stage to honor the panelists. Mr. Mrityunjay Kumar Shukla, please come on stage.
Okay, thank you. I would thank you, dear moderators and colleagues and speakers. I would really like to put on record my appreciation on behalf of the society for your contributions to the session in conducting an excellent session on the theme of sustainable energy from carbon neutral sources. We really appreciate, and I'm really looking forward to honor you next time when you are physically present in our next edition of the conference. Thank you so much.
So we have the next session at 1 p.m. So we have the lunch break. So